So, good evening. Glad to see that a few people are still here, even it's a very late hour already. So, welcome to the session. This is really a bit spontaneous. So, I have a talk tomorrow that is covering things a bit more in detail, but Mani and myself got together and thought, well, this is a topic we want to have a bit more interaction on. We want to talk to people, what are their experience? Are they using Linux on ARM laptops already? Do they have any problems with that? Are they planning to do that? And we just want to have like a bit of a session around that. So my name is Stefan Schmidt. I work for Linaro. I'm the team lead for the Qualcomm lending team. And Mani, introduce yourself.
I'm Mani. I work for Qualcomm. So I was an ex-Linaro, and I did the bring up of the ThinkPad X13s, which is based on Snapdragon Gen 3.
Yeah. So as you can see, we're both somehow related with Qualcomm. So a lot of these things are a bit more in-depth in these kind of laptops. So we are not so familiar with the Macbook sides, Apple Silicon side of things, but we're more than happy to learn about that and get engaged. Okay, as I said before, this is a birds of a feather. So that's not a talk. We don't want to just stand here and just expect like you listening in and that's all, right? I want to have interaction. And by that, I want to start with a few questions for you guys. So who of you has an ARM laptop and is running Linux on it? Okay, that's at least a few. Is it Apple Silicon or is it a Snapdragon laptop? Let's start with Apple Silicon. Okay, so Apple Silicon, there, okay. Snapdragon, the rest I would say is Snapdragon at that point. Okay, good, okay, thanks a lot. Anyone want to share some stories, some pain points? Or you go ahead, so we have a microphone for there. We have a few slides, we will go to that, but I really want this to be driven by what other problems you guys are having, what you're seeing, and so on. Then we can go into the other parts.
Yeah, it's not on. We can use this.
Okay, basically I'm using and trying to get Qualcomm Agent 3C for frameworks motherboard, and then I find it out the upstreaming there's still a lot of problem, especially for the basically if upstreaming is not done, Ubuntu, Fedora, all this thing is not done at all. So that is very painful. And then soon we given up on the agency, and then we moved onto the Plus. Same thing happened again. You know, it's so far behind from the product launch. You know, even now it's mass production for probably half a year now for the X Plus, but we still haven't seen anything. And the X Plus, the device tree up just probably last week or whatever.
Yeah. Okay.
Yeah. So it's very painful, and all we need is because we're doing mainboard. So I'm talking on behalf of my friend doing those mainboard for framework. And basically, if you so far behind to do all those ODM, you know, it's very difficult for us to get it going. For the framework mainboard, it's very painful. So all we expect is that, and we want to see if the chip is launched, is it possible to straight away announce a minimum basic version? It just give you a control or whatever, you know. And if GPU doesn't work, doesn't matter. But at least you need to get the minimum going so that the distro we can work with the distro to get something working, to get through our hardware cycles. Okay. Otherwise, it's just too painful and too long.
Okay,
thank you.
Yeah, so thanks a lot. So actually, yeah, we have seen these pain points. Obviously, from the development side, if you do this kind of things, you have a bit earlier access on that. But the idea for the X Elite, for example, was that once the SoC was announced, that there was an initial patch set posted. I mean, obviously, you have to kind of like an embargo from the company saying we want only to go public after the announcement of the SoC. That is fine. But this time, we are working to streamline that process and make it even a bit faster. We understand that especially for the Plus side, that was not a real SoC announcement around that so much because they started with the X Elite and then they later on pulled in the Plus as well. So that was not really orchestrated that well. But I agree. And on the distro side, that is a general problem, I would say. You see there's a Ubuntu concept image, but besides that, not many of the distros are really picking up on that and trying to like build something around. I mean, on the side of Asahi Linux, they do their own distro, all the spins of that. That is fine. What for the Qualcomm laptops you have, obviously, there's a community of people building images and making sure that you have like the correct device trees and everything set up. But there's a huge gap in what actually need to be done there. And I think we have a few slides on that. A lot of that goes back to the whole boot installation mechanism that's needed for that, and how a distro can abstract that and scale really to make sure it can support all these kind of devices. So pain point seen. On the Linaro side, we will work with Qualcomm to like try to get that out earlier. I can't make any promises about that, obviously, but we see that problem, and people inside the company see it as well. It's more like a question like how you can actually, at what point you can release it. If you are getting engineering going to like have it already for SOC announcement and post it a day after, that would be ideal, but we have to see if we can get to that. Okay, thank you. Any other questions, something someone wants to share before we go to the other decks? No, everybody's shy, nobody wants to share. Okay, fair enough. Okay, so I just go briefly over that. I think most of you either know that or not that interested. So ARM laptops is like it's not a new thing, right? It's really, really old with all the netbooks we had before. They have obviously not been as powerful as we have today. But I remember I had an NXP-based netbook, like it must be like 2008 or something like that. I mean, I still have that in my closet somewhere. I'm not using it, obviously, but so that is something, yeah. And then Chromebooks picked up. And then I think a big change was when Apple decided to also go with full ARM. That picked up the whole stuff around it. Obviously, it took a while for Linux to go to that stage where they actually can boot on it and like have it a really useful system. But then the other vendors picked up. So you can see like the X13S, as Mani worked on, with one of the first Snapdragons. And now with like the launch last year with the X Elite, there was like that's a very huge base of like available devices now. So, as I said, we are both not very familiar with the Asahi Linux project. So, if anyone has comments on that, I'm more than happy to take that in. From what I've seen and learned and observed from the outside here, is that I mean it's a project that is really powerful in terms of like the community they're building, all the software they're building is really good, but it's also very difficult sometimes on the Linux side at least to get all the code like worked on a new release, kernel release or something like that, or the rebasing you have to do. Obviously, the target audience might be different, because if you go for Asahi Linux and do a full spin of the Linux distro or something like that, you don't care about that. You can run it, you're a user and everything is perfectly happy. But if you're a kernel hacker and want to run on RC kernels or something like that and need to rebase all the patches on top of that, that's a bit painful. But again, that's a use case depending on what the target audience is. For this one, I tried to read up a little bit of what they're currently doing, and what I found a bit shocking, I have to say, the amount of lines of code and patches they have out of tree built up for a while. I realize they are now very much focusing on getting all of that upstream this year, and a lot of these blockers are coming from the usage of Rust, which is not like in the state in Linux where they can actually upstream everything they're having, and they're working hard even for things like the Mather forks they're having with the new UPA being in, so they're dropping all of that. So I see a lot of good progress going on there. Any one of the Asahi Linux users want to comment on like how they feel about it? Is this like a device they can use daily without any trouble, or is that something they're annoyed by? Or come on, some people have to use it here. There you go. Can you give me the mic? I want to give a bit of an interaction here.
I can say as running it on an M2 laptop, it's quite usable. The main blocker for me in terms of using daily would be that the Thunderbolt stuff doesn't work. So it works fine as a laptop, but then if you want to go dock it and use it with an external display or something, all that Thunderbolt, PCI over Thunderbolt, all that kind of stuff, those ports just don't work at all, at least on the M1 and M2 class devices. So as a laptop, without any peripherals, it's working great. The display stuff is great, but that's kind of a blocker in terms of wanting to use it as docking and portable and everything. So just as a practical use case, that's the main thing that I've found is a pain.
So is it not running for anything on the dock, or just for specific use cases like this PCI, or is there like because I mean,
I think the display port over the mini display port stuff over that port will work. I think that's what I read, but in terms of running it as HDMI or any of those types of things over the USB-C or Thunderbolt USB-C ports, that doesn't work at all.
Okay, because I mean on the X-Elite I have like 2 or 3 USB-C docks as well. Some of the functionality is working. It really depends on what it filters back into on the hardware on the laptop side.
Yeah, I think USB, basic USB 2, USB hub type stuff does work, but nothing that's essentially PCI over that is working. That's my understanding. Yeah.
Okay, cool. Thanks a lot. So I touched on that already. This was like last year. This was started to get products out. The one that got me excited here is that was not just one vendor getting it out, but really like a lot of them and a lot of different devices. So there's something for each and every one here, right? For all the ThinkPad lovers, they have like the ThinkPads available. For all the people that need to have like rules from the company, only buying whatever, a Dell or something like that. And then you have like more cost-sensitive device choices as well, especially with the Plus devices coming out. So that was nice to see that you have like a big range of devices being available. That being said, that obviously comes with its own set of problems. While the most of the stuff we are doing is like on an SoC level, and you have like a very good support on that already, the full integration for a product is really much specific on like how the vendor put it together, how it like is lined up, and then other things like embedded controller also come into play, how to do all of that. So that is like one of the things we are fighting with right now. Like how to get that for all the different devices available with minimal interaction with the actual vendors of the hardware. So that's something we are looking into. Okay, so on the kernel side, there are bugs, there are things that are not working yet, but we are also looking forward is more like the full use cases to get things going and come to a level where at some point we can really say, look, you install Linux on that one, ease as a breeze, and then you have like maybe the same situation as you have on x86 laptop. So that's like one of the things we obviously want to see. Right now, a few things we are battling is like the whole boot chain. Mani will talk about that, also the whole thermal support. What part of the system is handling what part, how they're all interacting, how to make the best out of it. And then other things like camera and video, making the full use of the hardware, offloading things, maybe like a YouTube video from your browser into the hardware, or like having full camera support, everything like video conference working on so on. So Mani.
So the major pain point of the ARM64 laptop is that there's no standard distro support. And that's not specific to Qualcomm or any other vendors, but the overall ARM64 ecosystem is that the boot chain is fragmented, and that was the main blocker for the distro people to pick up support for these laptops in their installer images. And as you might have already known that the ACPI implementation on most of these laptops is not the standard ACPI. It's the Windows ACPI, which uses PEPs, the Power Engine plugin for doing the power management stuff, and that is not actually supported by Linux kernel. It's only a Windows thing. And since these laptops are like Windows on ARM laptops, Windows on WOA, Windows on ARM laptops, Linux is not really a market for these laptops, and we are just bringing up Linux on our own without the vendor support. And that was the reason why the standard ACPI was not actually used, and we have to work around a little bit. But for most of the Linux use cases, we are going with device tree. Because at least on the Qualcomm platforms, device tree is pretty well supported because of the mobile chipsets. And so we are reusing device tree instead of ACPI. And the problem with device tree is that the device tree binary needs to be put into the boot chain. So someone needs to load the device tree binary into the memory before handing over the control to Linux kernel. So right now we don't have a standard way to do that, and that was the reason why even distros were not picking up the device tree support for these laptops. And so what's the impact? So poor distro installation, because there is no standard distro support. If you are using any x86-based laptops, you can just download the ISO, burn it to a USB, and then you can just install it. Unfortunately, that is not happening right now. And we need to have some manual update to keep the device tree and then the kernel sync, because even though the device tree is, if you know device tree, the spec guarantees the backwards compatibility, but in practice, that's not happening. So because device tree is ever evolving, and there is no fixed blob. So in concept, device tree is a binary, but it's a firmware, sorry. Device tree is a firmware. So once it is actually done, it shouldn't be modified unless you want to have some update very rarely. But right now we are doing development on device tree. So it is not supposed to happen like that, but that's why we cannot treat device tree as a firmware right now. And we need to keep both device tree and then the kernel in sync. So whenever you are updating a kernel, so there is a good chance that you need to update the device tree also, otherwise it will break. And so what are we going to do with it? So we are trying to use the UKI in the boot chain. So UKI stands for Unified Kernel Image. It's a UEFIP binary. And so it packages multiple components. It has the kernel init command line parameters, and then it can also package device trees. So all these components are contained in a single UKI image. And so it can also have the hardware IDs to map the device trees. Let's say that if you want to have a single installer to support multiple laptops, and each of these laptops needs to have their own device tree. And adding more to that problem is that you need to have a separate device tree for each version of the laptops. Even when you have a ThinkPad X13S, there might be multiple variants of the ThinkPad X13S. One might be with the OLED screen, another one might be with the LCD, and it can have multiple combinations. So as a silicon vendor, Qualcomm doesn't have control over that. It's actually up to the laptop OEMs who decide these combinations. And so unfortunately, it's a pain to support these combinations. That's why we need to have multiple device trees for each variant of the laptops. And it is also problematic to identify those variants. There is no standard way. And one standard way would be to use these hardware IDs, the CHID computed from the SMBIOS data to identify a particular version of the variant of the laptop. But it also doesn't work for all the use cases. And there are many crazy combinations like I think Lenovo uses reading some bytes from their EC, embedded controller, to detect what kind of device it is running on. And some vendors might use some GPIOs or some sort of combinations to identify the product variant. So it's very hard to support how to detect this variant and then use the proper device tree. So we are trying to come up with some sort of approach here. So one could be to just have the DTP come from the UEFI firmware itself. And unfortunately, it could, even though it could work for the newer laptops, the existing ones, it couldn't be done because the UEFI firmware is already out. You cannot just go and update it with device tree. So for the existing laptops, we might end up packing the DTPs in the UKI image and use some sort of matching algorithm to find the product that is running on and then pick the relevant device tree. It's not available right now, and we are just trying to experiment with it using the systemd boot and see if we can have some matching logic in somewhere in the binary and then detect it. I don't know. But right now, there is no out-of-the-box solution available. And this is a major blocker for the distro people to pick up support for these laptops. Any comments or questions on this side?
For those non-Qualcomm chips laptop, what are you guys going to do with it? Are you going to go through the same thing or completely different?
Are there any non-Qualcomm laptops out there in the market?
Yeah, it's coming.
Okay.
If you fancy a board, it's a pure ARM.
Okay.
It's 6 nanometers. You don't have all these hassle, purely Linux laptop. So then you don't need to work on these hassles, right? And clean Linux laptop. If you guys, I want you guys to support it. Otherwise, it's so hard for us to get around all these things. And probably you guys can do a reference solution to give some pressure on Qualcomm to do something better. It's ARM chips.
So,
You want to comment on that, or should I? Okay. I mean, obviously, from my side, I can't really control what Qualcomm or ARM or all the other vendors are really doing in that case. We give feedback what we think need to be changed in this kind of like firmware part, where we think we need that to have like a full-blown Linux system that can work out of the box. We give the feedback, we give like the technical background for that. They hopefully make decisions based on that. I can't really comment more on that. Let's see what the future brings there. So, but this one is still very much relevant for all what we have currently. So, and maybe the next generation, the next after, I don't know, right? That's really, we have to see what's going to happen in that space. But we need some solution for that. And while we seem to like go in a good direction on the technical solutions, it's really the question on the low level side, the question is really like how distributions are going to handle that and how to scale with all of that. Just imagine like the permutation of the different devices. I think right now we have like 7 or so XED platforms supported, devices supported, with maybe like 2 or 3 variants. Let's make it like 15 or so, right? That is easy. That is like 15 DTBs to put into the ISO, and you're good with that. But let's see if that really takes off, and like in 2 or 3 years down the road, we have like 100 devices with like so many more permutations, so on. Then it gets really a problem how to scale all of that and how to get that all sorted out, basically. So that is something we really need to think about, how we can do that. Is anyone here doing distro development on that level? Again, back to the interactive part. There you go. Can you?
Not really, but there is someone at Canonical doing a grub script which chooses the DTB based on the SM bias tables. I guess, have you seen that?
I mean,
yeah.
Go ahead.
I mean, yeah. I mean, to be honest, hardware IDs should probably work for most of the commonly used variants out there. But the problem is that I was told that hardware IDs cannot detect all the variants. And so, yeah, I mean, we can do the hardware ID comparison in the grub or in the systemd boot itself. And we also have an EFI application called DTP Loader that also uses hardware IDs to load the correct DTP before handing off to a kernel. So unfortunately, that cannot be used across all the variants.
And on top of that, while Casey did a really great job to get U-boot working on all the Qualcomm stuff, that doesn't mean that's running on all the devices out there. I mean, you could have a setup where you like chain load that and everything, but then we are back to a situation where distros need to be very specific in their distro installers for this type of devices, and that's actually what we want to get off from, right? I would love to have a system where we can use all the firmware that's on the device, how crappy it is, and find a solution that is scalable and generic enough in the distro installers that can still support all the devices, at least for the initial install. That can still mean that the DTB is like not fully fledged and not everything is working for the first initial install, because after that, it doesn't matter. You do updates, you put your DTB in, and you have like newer features and everything is working. But the initial stack, that is really a step that's really the most painful step at the moment, so yeah.
And Casey's approach, I think, is to use U-boot stub, right? So it's an EFI stub, it jumps into U-boot, and then you have to have Qualcomm drivers, right?
I mean, she has all that working on her laptop. That's obviously, that's the different thing. And then we have also talking with her, like, use like a UEFI variable to like identify instead of the chips IDs and so on. There are different approaches, but the problem again here is, to do that, to write a UEFI variable to match like the string, so you have actually a good matching afterwards, you need to do a pre-step. You need to have something that tells your system, oh, I'm this in the system, and I put that into a UEFI variable, and then later on the installer can pick it up. I would love to avoid all of that. I know that's maybe not be possible, but yeah.
It should be possible. I mean, it's in the SM bias tables, right?
It's where?
In the SM BIOS tables?
No, SM BIOS doesn't have all the combinations. So,
But how does Windows know?
sorry?
Okay, you have the SM BIOS and so on. That's basically like the chips and so on. They have that. That is like for a good set of different SKUs that are available. But then you have other situations like Mani pointed out. You have something like reading some bytes from a specific part of the memory. Some have like different GPO combinations where you have like whatever 4 or 5 different variants and so on. That's all different stuff that if you have the knowledge from the vendor or you reverse engineer this, then you might find a spot in your lower level bits where you can actually read that and then select the correct. So for example, one of the T14S I have there that has like a normal screen and an OLED screen. It's not in the hardware chips ID, so it's not, you can't detect that easily. So it's really difficult sometimes to find the right combination of things to have like the matching SKU to like load the right DTB for that. So yeah.
I'm just curious, you mentioned vendors and most of them just supporting Windows. Are any of these vendors at all, the actual manufacturers, engaging on this? I know Dell has done like developer editions of their XPS 13, but I don't think they're offering that for the ARM version, right?
So that is one of the big hopes. I love the interaction. That's one of the big hopes I actually have, that they're picking that up. We know they pay close attention to that. We have some contacts in the companies that actually are looking what we are doing and testing out internally. But that doesn't mean they're really going full steam ahead and putting like their own engineering resource in that. So a few things you can see in public, so I'm not spoiling anything here. Dell people review patches for DTB for the Dell XPS variant of that one. So people do that, they test it and so on. So that is going on. On the Lenovo side, they actually push the firmware for these specific devices into Linux firmware. It's the only vendor sadly doing that at the moment. But so there are the bigger companies, they pay attention. I guess the smaller ones have more troublesome, but they never had like developer editions for their product line either. So I would hope that at some point they might do that for upcoming devices as well. But right now they are looking from the edges, let's put it like that. So, yeah.
So the actual real problem behind all this mess is that there is no market for Linux on the Windows on ARM the Linux on the ARM laptops. So there is a market for Windows on the ARM laptops, and that's why vendors are actually actively engaging with Microsoft for pushing out Windows build. But the same is not happening on Linux because there is no market, and probably in the future there might be some market like Intel. But right now, since there is no market and the SoC manufacturer is also happy with whatever they were offering for Windows, and the OEMs are also happy, but only the users who want to run Linux on these ARM laptops were not happy. So, and Linaro is in the middle of that. So hopefully this will get fixed in the future when the company starts seeing markets.
Yeah. I mean, it's business driven, right? So.
I was going to say from the distro standpoint of, I think I like the DTB loader approach because, like, I know some distros will use Grub, some other ones use system dboot, and if you use the DTB loader, it just makes it easy for, like, it separates it out from there. That way you can put all the ugly logic of, like, you know, if you have to read the GPIO pin, for example, to figure out which laptop this is, you can just shove it.
Okay, so would the distros be in charge of like making sure that the DTB loader is doing that, or would you expect a different project to do that? Because all the feedback I got so far is that the distros would love to like not touch this thing at all, right? So I mean, the thing is,
I'm not in an official position to get it, but I think it would be nice though. Let's say if we had like the DTB loader project, and then if we could just make that the boot AA64.EFI, and then have a chain load over to the next stage, like Grub or system dboot or whatever. I would think that would be easier to talk the relevant people into it where I work to like, hey, we should do this. You know, just make it transparent and it'll just work.
I mean, my fear around that is that it would be something that you might run for this specific type of device or class of devices, and there might be enough to be worthwhile, but then you have like Apple Silicon, you have like maybe other ARM laptops coming up at some point and so on. They might be very different and so on. And then I wonder like how the distros want to have like, make sure that they are selecting the correct stuff here. So yeah, I can see why distros like want to get that off and like have that like in DTB loader, for example, but yeah, make that really a really functional setup where the user would not be the person that need to run that up front, right? I mean, I want to have a solution where they can just download the ISO, put it on USB, and install it, and not having like an extra 1 or 2 steps before preparing the system. I mean, that can be automated, it can be done very well and smooth for the user, but still it's an extra step that's in process. You have something?
Yeah, I actually agree. That's the right way to go here, because you've just explained that the logic can be complicated. It's not just a trivial transformation. So you need something in there. The other problem is that it's all very well to put the device tree in the UEFI, or sorry, not the UEFI, but in that early phase thing. But as soon as you boot a different version of the kernel, is it going to be compatible? You really want to use the same device tree as the kernel version you're doing, right?
We're back to Mani's point, like device tree should be fixed and considered done as firmware before others, but that's sadly not how it works.
It's not realistic. You're going to basically get camera or high-end camera support 3 years after release. You've got to be able to support it. So I think that's a very good idea. The way I see it, it's a very good idea, and in terms of maintenance and so on, it could be something that people contribute to. I actually don't think that just talking about what Casey's doing, I think the stub thing is not really very scalable, because you've got to then put all the support into U-boot to support, these Qualcomm platforms, and maybe not everything, but you've got to have some drivers. So with an EFI app, you don't really need to support very much. Yeah, I'm sorry the EFI is broken, maybe the keyboard doesn't work or something like that. Fine, live with it. But at least it will actually boot into Linux, and then things will go.
I mean, on the X13S, right, they had like the middle ground there where Lenovo actually put a DTB in a firmware update later on. So that was something that could be used for the initial boot, like a boot shell or whatever you want to have, and have like it for the initial installation. So that helped a lot. Obviously, that means that, I mean, you have been running it. I don't think you have been using that DTB for your day-to-day work, right? You have been running something that has all the features enabled and so on. But that happened later on. That happened when the distro was installed and the kernel updated, and then you put it all in the right place and make sure that your bootloader finds it. So. Okay.
Sorry, I've got one more point. The canonical way to find, I mean that with a small c, sorry, to find a device tree is using the compatible string, right? Or is that controversial?
Oh, well, I mean, obviously we need to use the compatible to identify a device tree binary. But then how would you choose if there are multiple? Obviously, for a distro installer, you will have multiple device trees, right? You cannot just have a single installer for a single device, right? You need to have a common installer that is going to support multiple devices. And for that, you need to have package multiple device tree blobs in that. And how would you identify which device tree blob to choose? And that's where we need to have some data to compare against this compatible. So it could be hardware ID, or it could be something else.
It would be a compatible string.
And the compatible will be present in the device tree blob to choose which one. But then how would you match against a compatible?
So the machine has to have a compatible string. This EFI app we're talking about needs to somehow come up with a compatible string using whatever nefarious means it wants to, SMBIOS, GPIO, looking at the display.
It again boils down to the UEFI firmware implementing that, right? So
sorry?
It again boils down to the UEFI firmware supporting that. So if your EFI application has to query something, then the UEFI firmware has to support that, right? Or you want...
Yeah, the SMBIOS table is supported. If there's GPIO drivers that you have to hack in there, you're going to have to do that. I don't know. But yeah, once you have that compatible string, the problem is solved. And because it's the canonical way of doing it, that's what we should do.
That basically means we are back to having like an PE application and having something executable on that level, looking into the system, and then setting the string, something like in UFE variable or something like that, and then you can match again. So that's an option, definitely. What we try to like get an idea here and run with the community is like, what is the best approach they're going to do here? For us, I mean, to be honest here, I mean, we can install the stuff on the laptops. It's not really our problem, right? It's more like how we can make it easy enough for like the distros to pick it up and for the user to actually go and do that. Because I mean, especially in the XLE stuff, there's like a lot of spins for all the different distros and so on. People are nice enough to do that, to actually get it installed and so on. But it's like still a big pain for everyone to install it. And that's even, I can tell you, that's even in our own teams, like people that know about all this stuff and they still struggle like and are annoyed in doing that. So that's really something that needs sorted. Okay, I think I got a lot good feedback here. Anything else on that one, or should we move to the next topic? Sure.
How did the Android AOSP GKI handle this? I mean, the vendors and the OEMs, they actually upload the DTB and their DTB overlay. This is just money.
Well, I mean, they have complete different bootloaders and like complete different stacks. Yeah. So I mean, it's not a technical issue that you can solve. It's more like on this one, it's like how we bolted on something that's already released. If you put it in the design and the architecture of the firmware, like makes that correct, or you are in full control of all the blobs to update, all of that would fix it. So for example, the X13S with updating firmware to have a device tree, you can fix that. But I don't think we are in a situation with these devices to do that. And yeah, so that is the problem basically we're dealing with right now.
Okay.
Okay, cool. So next one. Sorry. There we go.
Yeah, the next problem with these ARM64 laptops is that thermal. So we often joke inside the team that the ARM64 laptops cannot be used on a lap. So I mean, if it's a laptop, obviously you have to use it on a lap. But then if you are trying to use it on a lap while building a kernel or doing any heavy task, and you are going to burn your lap. So it's actually a problem for all the ARM64 laptops because we don't have a proper way to handle the thermal problem. And then so it's actually quite simple on the x86 platforms because most of the things are handled by ACPI, and then we have this thermal daemon supported by Intel, and it's actually a user space framework, and it actually queries the thermal zones, and then it has the cooling devices. So it just has the config file, and that actually tells the daemon how the thermal zone is mapped to the cooling device and then how it should be controlled. And unfortunately, that cannot be done on these ARM64 platforms. So we do have the thermal zones, we do have the cooling devices, but we don't have an obvious way to map this. We tried to use the thermal daemon, but then we found it not be very useful on these devices, unlike on x86 platforms. So that's actually a problem right now. And if you are trying to use it for any heavy compilation task, like only two things will happen. Either the CPUs will get throttled. So once it reaches the some hardware specified limit, so the CPUs will start throttling because we have the in-kernel thermal zone inside the defined in the device tree for most of these laptops. So we are using CPUs as the cooling device. So once the laptop reaches a certain temperature, like say 56 or 60, then the CPUs will start throttling, and you will not achieve maximum performance. And the worst case, the laptop will actually shut down, because once the kernel misses the throttling, and there is the hardware-based safety critical mechanism that will kick in, and then it will reboot the laptop or shut down the laptop. So these two things will happen right now, and it is going to be, and it is actually a user visible impact of using this. And then the third point is that the thermal domains are not throttled properly. As I said, once the laptop temperature reaches, we are just blindly throttling the CPUs without without identifying the cause of that temperature rise. So we will never know what is causing the temperature to rise. Let's say that if you are charging your laptop and then you are trying to do some compilation, then the charger, it can also generate some heat. And that heat can actually increase the skin temperature of the laptop. And what we currently do is that once the skin temperature reaches some temperature, and then we'll just start plotting CPUs without cooling down the charger or without reducing the charging current. So these kind of issues really present in current laptops, and it's not very straightforward to fix this, because on these laptops, the charger is actually controlled by EC, and we don't know how to talk to the EC. So because the EC is actually not controlled by Qualcomm. The ECs are controlled by the laptop vendor, and the OEMs can choose whatever EC. They will just pick up microchip EC, and then they can do their own firmware. And only the Lenovo folks will know how to talk to that EC and then control this stuff. So we cannot just go and have an EC driver for all the laptop variants out there. So it all adding to the mess.
And in addition to that, I mean, the EC is one part, but also the whole thermal design of a specific device is completely different from one device to another, right? I mean, depending on what kind of material it's using, where these things are placed on the thing, and it's like very much different between different products from the same vendor, and even more different from like different vendors as well. So without any knowledge in that front, it's very hard to do that.
I mean, similar to the previous slide, isn't this also a pain for Microsoft? I mean, it seems like Microsoft has a lot more influence, obviously, than the Linux community, right, on these types of things. If it's a pain for Microsoft, if it's a pain for us in the kernel, we know it's a pain for Microsoft. Seems like there's some potential collaboration there to work with them to exert their influence.
I'm not.
It's not a pain for Microsoft because they are using PEPs, and in Linux we cannot use that. So we don't know how to actually control these things. So on the Microsoft, the Windows thing, it's all buried in the PEP driver.
Oh, okay.
So
Does that include, besides thermal, does that include all the idle state stuff? So the PSEI type stuff that would be happening in firmware?
I don't know much. I don't have much insight into that, but at least I know that I know for a fact that all these power management stuff, like talking to the EC and everything, is all handled by the PEP drivers.
Okay.
So.
Oh, sorry. And I don't understand PEP at all, but does that mean that the OEM ships a Windows driver for their laptop?
Yes.
Yep.
So basically what it does is, PEP stands for Platform Extension Plugin. So basically that is just code that normally would be in ACPI or something like that, but instead it's on the Windows side. And normally that is like supplied by the hardware vendor. So it's not really a problem for Microsoft at all, because they get that over an SDK or whatever API they're having to interface with that. And so they're good on that front. And this is, I mean, one of the big problems, because a lot of the ACPI tables that we would expect on the Linux implementation are either not there or empty, so we have no chance to get that working. It's not even something that we need to extend the ACPI implementation on Linux to get that working. Without the correct data or anything being available at all, you can't make that work. So.
I mean, there is one thing, often with ECs, there is an ACPI interface which is standardized across things, but that's probably gone away with PEP, has it?
So we now, for example, when working with Qualcomm on their reference designs, we now have a little bit of like understanding how to interact with the EC, what the commands are and so on. They promise us to write a driver for that, for the reference stuff, which is nice, but it doesn't help you for like the next Lenovo or Dell or something, because they might have chosen something similar to the reference design, or they might not, because they could have just picked something from the x86 line, because they have like their whole firmware set up in a way they want it there, and the thermal design and everything is very similar to that. So they want to have the same interface and so on to that one. We just don't know. That is again back to the point where we said we need more engagement with the vendors at that point to help us out. And
I'll just make one more comment. Because, for example, Dell my previous role, we actually got an open source driver, I think it's in Linux, for the Dell EC. I wonder how secret these OEMs consider that API. Some of them think that you can do terrible things to the laptop if you make EC calls, and some of them base their sort of security, some of their security stuff in there as well. But maybe, I don't know.
Well, one could argue it's a security problem at all, right? I mean, it's not impossible to reverse engineer these kind of things. If you don't put it there, like if you don't build your system in a way that you can do these kind of things, then you're just hoping for the best. And by not, well, but that's a different story. So I guess engaging with these vendors will help us to like get their interest. And if they see the potential for like having a business use case on that, will help as well. We talked about that, like if they're going to go for like developer edition of these kind of laptops on the ARM side as well, that would be like one of the driving factors. Would still mean that a lot of the, I wouldn't say cheaper end, but like devices that don't have developer editions would still be struggling to like keep up on that. But to be really honest, that doesn't sound so different from like 20 years ago when I had my x86 laptops and so on, gets it going. I worked on that was still IBM at that point, on a ThinkPad ACPI driver, because they needed a specific one to like do like whatever specific keys and so on. And I worked on that to get my very old ThinkPad working at that point. So that's not different from what we have right now. So, but you had a point.
Yeah, I think I agree that basically we just need to give you ball and then talk to the SoC guy, and then we'll get the upstream going and we can get all this thing done, man. Seriously, you can't just limit it to Qualcomm. Qualcomm is really bad on the development board. And then the second thing is that all the Qualcomm products, all Windows on ARM, it's very hassle. The chip we got, we got a 6 nanometer chips and the most powerful ARM v9. And then certainly, I think the SoC guy under our influence in our framework, and we can get these things sorted, man. Seriously, it just need more deeper collaborations. It's not, the work for Qualcomm is just a hope. I can't, I try to get agency work on a laptop. I can't. But basically, I give up, completely give up. And I'm sure, there's a lot of chips, like Rock chips, our winners coming, all these powerful ARM chips. I'm sure they are willing to collaborate with you guys, because at the moment it's just the focus on upstream, and then the collaboration from distro, and then the nano is completely broken. It's not broken. You guys only work on the Qualcomm because you don't get any ball. But when we have a non-Qualcomm one or even Qualcomm one,
once again, so right now we work with what we have. I'm pretty sure there are capable ARM chips on the road to actually do laptops and so on. They're there, they will come out. Right now we're working with the Qualcomm side, that's what we're having, so we have to deal with these parts. At some later point they will come. How good they will work with the upstream community to get all these things sorted, especially the OEMs and the vendors coming after them, we have to see. I'm pretty sure there will be good ones and there will be bad ones. It's the same situation as always, right? Some of these companies will understand that it gives them a benefit to actually work with us and get things upstream and make it as smooth as possible to use these devices. And some say they only focus on specific business cases and they don't care about the rest. That's what we are currently seeing with Windows on ARM. So that is what they have. Once we have enough momentum to demonstrate that these devices are also really good with running Linux on them, and we have like people that are demanding them, and we have like businesses demanding them and so on, I think that will change. And it doesn't matter if it's like whatever ARM vendor, if it's Qualcomm or whatever else, as soon as they see a big business use case, they will change that. It's just the question how we get to that point, right? Okay, anything else on thermal?
I mean, back to these easy problems on these x86 L8 laptops, there is a fan. And in order to control that fan, we need to talk to that EC driver. So right now, we don't know how to talk to that EC driver, so the fan is pretty much useless on these laptops. And we thought about reverse engineering that. I think one of our engineers even reverse engineered the I2C sequence that need to turn on the fan, and that's only on Lenovo. And then he realized that he has like 5 to 6 variants of other manufacturers. So
on top of that, you need to be careful with that. Not like damaging the system, but also like to have the best outcome coming out of that. Because the EC sometimes might have logic to when to spin the fan, because it might also know what the temperatures in the system are, and not on the Linux side. So you need to have like a cooperation between these different compartments that actually make sure that you're driving like at the right points the fan and so on, doing like passive or active throttling and so on. There's a lot of things.
that's one of the reasons why we couldn't write a proper device driver for those ECs using reverse engineer things, sequences. Okay.
Okay.
My question was just, definitely everything goes through that PEP driver. There's literally, they don't even implement the basic ACPI control of a fan.
Sorry, can you come again?
I mean, on x86, right? If you've got an x86 laptop, that stuff is sort of done through ACPI.
So on x86 laptops, ACPI has, I mean, there is no PEP. So the ACPI has this power management thing going on using the system states or whatever. So there the kernel can actually invoke the P states or the D states, and then the ACPI firmware itself will transition the device to that state. But yeah.
So it does fan control, but you're saying that's just not even implemented at all. Okay. That's really crazy, isn't it? Yeah.
To be fair here, we're bashing a little bit about that, but to be fair here, ACPI, so I haven't looked at the specification myself, but I talked to quite a few people why we have this kind of strange situation we have right now. And the feedback is that it's not only like because it's easier that way, but it's also ACPI is lacking in describing the way these kind of things are handled on an ARM system versus on x86. That means the ARM vendors need to go ahead and if they want to go with ACPI, they need to go and bring in their own interests and like how something is described on their level to bring that back to the ACPI specification to make sure these kind of things can actually be implemented because they are specified. So it's like a mixture of both, right? It's not only one thing. So I just want to make sure that we are not only bashing on all of that. There's also missing parts in the spec to actually describe the full system here.
I'm sure this is a stupid question, but you can't just run the fans open loop?
Well, we are coming back to the problem that the EC might have a different view on the thermal system that's running versus what we have on Linux, and then how you use that. I mean, yes, you could run them all the time, but I'm pretty sure people get annoyed by that because they can get very noisy and so on.
Yeah, but it might be better than the thing turn it off, right?
It's true, but I can tell you, we have like, one of my engineers have like a device that has a fan constantly on, and he hates to put the device on just because of that. So I get your point, that's something to help cooling it down and so on, but it's also, in the end, it's just another mitigation, either throttling or running the fan all the time. So both of them are not ideal. So, okay, so we have like 10 minutes or so left. Any more comments on that, or should we move to the other topics? I mean, we can stay on these if you guys have more on that. I'm really loving the interaction by now, I have to say. Okay, now I said that I want to move to the next slide. Nobody wants to speak anymore. I get it. Okay, so two more things. One is the video offload. So that's something I looked into a little bit on myself. So we have on these devices, obviously, like encoding, decoding, offloading capabilities, and so on. That's very common on ARM. Like it's for specific codecs, it's for specific resolutions, and so on and so on. And this is on the hardware side, on the kernel driver side, that is making really good progress, and that is mostly done. We're exposing all of that over the Video for Linux 2 interface. So that is like something, it's possible to offload a video playing something like GStream with GStreamer or FFmpeg or something like that. So that is nice and good. But if you want to have like the full benefit of that for a user going to a website, opening YouTube, and want to like play video, that would still all be software. There would be no offloading or whatsoever, right? All of this logic is not there yet. So this is something that definitely needs work. Chromium has made some good progress. Initially, it was only designed for like very purpose-built, I think they started with some MediaTek chipsets, It was really coming from the Chrome OS world. Then they enabled all of that, and then they understood, okay, this is the hardware capability of that, and I can just push that down. They enabled that now for generic Linux support as well. So I got it running with Chromium with only like a few patches, and that was able to like offload video from the browser to the hardware down. That is still not upstream or something like that, but it at least shows that the upstream is making good progress in that direction. This is a problem to like address over time, also with the distros to get that on the Chromium side in, but also like enable the correct flags and everything like that. But yeah. On the Firefox side, for example, using FFmpeg in the background, that's not there at all. So there are things like how we can make that a first-class hardware acceleration method in FFmpeg as well, how we can use that. That's something Brian from my team has been looking into a little bit, but there's no final solution for that as well. So, yeah.
For the work in progress patch for Chromium, is it a change inside the Chromium side or the outside Chromium side?
I would need to look at the patch set again. I think it was only enabling some specific build flags and running it with the correct parts. I think most of the stuff is actually now sorted out. I think it was like down to 3 patches or so, but I would need to check again.
Okay, so and if just at the end of the day, right, Chromium had to make changes and they had to accept it. This is really hard job, man. Will you guys be able to talk to them?
Luckily, I hadn't had to do anything of that. So there was other people doing that already. So I honestly, I don't know. There was some other consultancy companies doing that, and they helped to like get that all upstreamed already. So I will need to look it up again, to be fair.
Yeah, man. Otherwise, the SOC guy or the product guy to build Chromium, that's impossible. They every 6 weeks have a security patch.
I know.
This is impossible.
And even building that one, so I was trying to build that natively on my ARM64 laptop. That was a pain. Then I cross-compiled it for like 8 hours or something on the x86. So it's a completely different story, but don't get me started on C++ and Chromium and so on. So it is something, but in the end, that's something you need. The user need to have something like that worked out. Luckily, it is something that is being worked on. Again, that will take some time to like get that all sorted out on the upstream projects in distro. So, Mani, can you give the mic?
What about Firefox support?
I just said that. So that's something we need to figure out how to do that best. I know that Brian looked into that a little bit, and what would be the correct place in the media framework stack of Linux, how to put that, and how to get it in, and then also enable it to make it like a first-class citizen. So yeah, it's definitely a question that's there, but that's not solved yet. Okay. So very similar but different camera side. So camera is getting all the good days where you just put a USB camera in, it gets detected because it's a standard USB device, you have like camera working and so on. That is not how it normally works on ARM systems. There's good reasons for that. There's like efficiency, there's like integration, there's like a lot of things that you can like use with other components together, but still it means that you need like complete different support on that. Surprisingly to me, my last x86 laptop I bought had the same problem with the MIPI camera, and I only realized that at some point when I was on a business trip. I had the laptop for like over, 6 months or so, and I only at home, and home setup was like a dock and everything USB, blah, blah. And then I was going on a business trip and wanted to do a video call, and the camera didn't work. And I was like, what the fuck is going on? Sorry for the language. And I was like, trying that out, and then I really gone to audio only, and then after the call, I figured out, okay, there's no upstream driver for this camera, and so on. I was like, okay, wow, that is like, it feels like an embedded system again now. So there is camera support. We have camera support in Linux. We have then, on top of that, we have libcamera to run all of that. And I've seen it running in Firefox, for example, where we have like, on these laptops, where we have like the camera support. This is obviously not as good as the hardware support could be. We have no drivers for some of the ISP stuff and so on. That's still secret source from the vendors. But at least for the basic stuff, we can get that going. On top of that, we have like soft ISP to do that on the CPU side. And Brian just pushed a patch set out for as an RFC that is doing like GPU ISP basically, offloading some of the more compute challenging algorithms and so on, putting that on the GPU side to do that on that front. That still means if you have like real hardware silicon support on that, that's obviously a lot better, but that's normally something that is very well done on the Android device and so on. But for compute, I think that's a bit more complicated at the moment. But at least that is something that is working. I saw it at least for some video conferences, people joining in with that one, so that is good progress there. On the support for all the kind of different devices, we are back to the situation, how they're wired up, what kind of sensors they are using and so on. Sometimes we have the right init sequences, sometimes we don't, sometimes we have access or can ask nicely like how they're wired up from the schematics and so on, sometimes not. Sometimes people reverse engineer that. So there's progress on this, but that's a normal slow progress you would have on that front. But yeah, that's all we have on the camera side. Any comments, questions on that?
Does Windows use the ISP?
Yes. But I don't know how, because I don't know Windows, so.
And these platforms are not supported by Android, right?
Well,
SoC.
okay, the SoC itself, I don't know if they have an Android port for that internally. I never looked into that. But obviously, like, a lot of the building blocks are similar on different SoCs as well. So it's like some things, they will have support for that. But yeah, I mean, it only brings you so far if you have like the kernel portion open and then you have like some specific parts outside that are not. And so, yeah, that is...
Do you think that, like Qualcomm? Do you think that Qualcomm, for example, might in the future consider open sourcing some of their ISP support?
Honestly, I can't comment on that. So even if I would know, I would not allow to comment, but I don't know, so that's even better for me, so I can say I don't know.
Because I know, especially with like all the IoT products where they're upstreaming a lot more stuff for the IoT product line, it would definitely help them there.
It hurts, but it always goes back to like business use cases. If you have like enough customers coming in, demanding that, wanting that for like their specific use cases, it's different. Then they are more able to like push in that direction. We are pushing from our side. You can believe that, but it's always like we are basically like on this front. We are like working for them, and so I mean we give feedback, we give technical feedback. We say I think that is the right direction to do. They don't have to take that. So that's obviously, and sometimes they have good reasons to not take that and make it just their secret sauce because they are like have a competitive advantage over that. I mean, it hurts on the community side, it hurts on the open source side, but on the business side, it sometimes certainly makes sense. So.
But that actually applies to other vendors also, right? So
yeah, I mean,
even on Rockchip, it's their ISP is actually protected, and we don't have the 3A algorithm open to public. So I think libcamera is coming up ways to work with those kind of protected IPs in a way that the chip manufacturer doesn't need to open up their 3A algorithm, but still we can just use it in the user space. So we might end up with something like that, but we don't know.
I mean, the thing is that camera is a really differentiating factor in Android devices, what people are buying, right? I mean, if you have a good camera in your phone or something like that, that's a big part of like decision-making process of people like buying a device. So I think that all comes from that. So they want to make sure whatever direction that is going, this part is like kept for them, and that's their advantage they're having. So that's basically it.
And the same easy problem also applies to camera because there are two different components here. One is the camera sensor and another one is the ISP. And if they use a different variant of the IMX sensor, then we have to go and add support for that, the driver. And obviously we don't know how that is, how the chip is actually wired up. So for that we need to have the data sheet. And if we have the data sheet, we don't know how to program that camera sensor. For that, we need to get the data sheet of that sensor. For that, we need to sign an NDA with the IMX guys. So it's all crazy problems out there. So
I think that's all we actually had. Yeah, and perfect. Yeah, 3 minutes over time. Thanks a lot for all the interaction with you. I'm more than happy about that, all the feedback. And yeah, I will talk about that tomorrow, but everybody was here. I don't think that's so much interest for you. Okay, bye.